This 1986 BBC Master microcomputer is quite noisy when it's switched on. Can this be improved? Let me thank today's sponsor PCBWay and let's take a look at it. We worked on this BBC Master before on this video and the unit was working totally fine, and I did notice that the speaker was on the noisy side, but I was told that it was totally normal. But some of you left some comments saying that maybe that noise that I was hearing was way too loud. So today I'm going to revisit this BBC Master. I'd like to see whether we can improve on that noise. I do understand that these machines are supposed to make some noise through the speaker. I just feel that this is way too noisy. In a quiet living room, this would drive me nuts. So I think we need to understand whether the noise is coming from the audio that goes into the little amplifier that drives the speaker, or whether maybe the voltage driving the amplifier is dirty. And so the voltage noise is being amplified by the amplifier and played back through the speaker. So first thing first, let me take a reference of this noise so we can compare the before and after. Now, looking at the schematics, the little internal speaker is getting the sound from a small amplifier. It's an LM386, and the LM386 is getting the sound input from an LM324, which is an op-amp. Now, as anything where sound is involved, you need a positive and a negative voltage, and I can see that the LM324 is driven by the plus 5 volts and also the minus 5 volts. And by looking online, it looks like special attention should be placed on the minus 5 volts, which is really not driving anything in this computer. It's just the sound, and I think maybe the drive output, and not many drives actually use the minus 5 volts. I haven't recapped the power supply, so that could be a problem. First thing first, let's check the how good the 5 volts and minus 5 volts are using my oscilloscope and see whether by any chance we have some noise coming from the supply itself. I'm probing the minus 5 volts coming directly from the power supply. Let's take a look. 3, 2, 1, go. Let's switch to AC mode, so to remove the DC component of the signal so we can magnify the vertical resolution. And it looks like we have approximately 500 millivolts of noise, which is probably quite a lot for a 5-volt signal. And the main noise seems to be like 24 megahertz, which is a bit too much on the high side. I don't think there's anything in here which is running at 24 megahertz. So that's maybe just noise coming from somewhere else. Maybe I zoomed in a little bit too much. Let me try at a different magnification. And no, really I don't see anything. So let's take this as a reference, and we'll see later on whether we have an improvement or not. And this is positive 5 volts with exactly the same resolution we had a moment ago. So you can see immediately that the noise, the vertical noise, is much lower than the minus 5 volts has. It's only 152 millivolts, so maybe this is something we can look into. I'm not familiar with this power supply, but usually the negative voltages, because are only used by a few components, they are generated by linear regulators, so I wouldn't expect much noise coming out of it, but we shall see. Now the next step would be to take the same measurements where the sound is actually being amplified, so at that op-amp. Let's take a look. This is the minus 5 volts arriving to the operation amplifier. It's even worse. We got 1.13 volts of noise on a 5 volt signal. I think that's way too much. So that's probably where at least some of the noise is coming from. Let's check the plus 5 volts. And with the same scale of the minus 5 volts, you can see the plus 5 volts is better, even though it is still quite noisy. So what do we do to try and fix this? I had a look at start.co.uk and I found an old post from 2011 from Retro Clinic saying that we can improve on these by replacing some capacitors, as you might expect. So first thing first, we should really make sure that the voltage coming from the power supply is okay. And we noticed that maybe it's not, but we'll have a look later on. Right now, what they recommend is to replace C15, which is a tantalum capacitor, with a new capacitor. Now I'm going to replace that tantalum capacitor with a good quality low ESR electrolytic capacitor. Now that capacitor is on the minus 5 volts line, so it makes sense that maybe by replacing it we can improve the signal noise. But nearby I also see C15, which is an identical tantalum capacitor on the plus 5 volt going into the amplifier. So I think I'm going to replace both with good quality electrolytic capacitor. Number one, because I don't have those tantalums. Number two, because I think it's going to be totally fine. And nobody likes tantalum capacitors anyways. So let's swap those two capacitors. The two 10 microfarad tantalum capacitors read 10 microfarad, but one is reading 4.1 ohm as ESR, and the other one is reading 11. 10 microfarad 11 is not so bad, but definitely reading something different. And I'm going to replace them with these two Panasonic. They read 10 microfarad and 7 ohms of ESR. The 4.7 microfarad tantalum is reading 5.1 and 34 as ESR. Again, it's a low value, so 34 is not so bad, but I'm going to replace it with this Panasonic, which is reading 4.7 and 3 of ESR, so much better. And the 47 microfarad electrolytic is reading 1.9 as ESR, which is pretty good. And I'm going to replace it with a Nichicon, which is reading 49 and 1.2. You know, when it comes to these old machines, there's plenty of projects online to update them, expand them, mod them. It's literally, there's a massive community for the BBC series. And if you stumble on a project online which requires a PCB manufactured, well, PCBWay is your stop. The process is very simple. You just need to upload the Gerber file on PCBWay.com. The system is very simple, more or less automatic. You just need to select the postal service and the PCBs will be delivered at your place. PCBWay has been my trusted partner for PCB manufacturing for quite some time, and I can guarantee you that you won't be disappointed. The quality is always top-notch. Take a look at PCBWay.com, and the link is also down below in the description, and let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible, so thank you very much, PCBWay. Now, let's continue with this BBC Master. Have we managed to improve the noise? I don't think so, but let's try. 3, 2, 1, go. Wow, we have! It's quiet! It's completely quiet! I was totally not expecting that. Those capacitors read okay, completely quiet. Well, since we're here, and clearly RetroClinic knows what he's talking about, let's continue with their recommendations. The second recommendation is to bridge pin 2 and 5 of the modem sound socket with a 1 kilo-ohm resistor, and number 3 is to fit a 10 nanofarad ceramic capacitors across pin 3 and 4 of IC13. So let's do that and see whether we are getting any further improvements. Let's see whether the 1 kilo-ohm resistor on the modem connector has made any difference. 3, 2, 1, go. I think he has, just a little bit. It was pretty quiet before, and now I think it's even a tiny little bit quieter than before. The next step on the list is to add a ceramic capacitor, 10 nanofarad, between pins 3 and 4 of IC13. IC13 is the LM386, is the final amplifier for the speaker, and the capacitor would be in between the signal coming in and the analog ground. So let's do that and see whether we get any further improvement. I'm quite curious now. I'm really curious now. We'll have improved. Let's test it. 3, 2, 1, go. Probably, it's difficult. Probably have to compare in post-production, even though I have some noise here around the lighting and I've got some fans running. But this is amazing. Compared to where we started from, this is night and day. Absolutely fantastic. Now, out of curiosity, I went to measure the -5 volts on the LM324 just to see whether I could see some improvement. But as you can see on my oscilloscope, it looks unchanged. I still have that 1.13 volts ripple, which is a lot for a 5 volt signal. And I was like, well, if the oscilloscope says we haven't improved anything, how come the sound is so much cleaner? And then I thought, what if the noise is introduced by this long lead? So I went ahead and removed the lead and checked directly on the IC. Here I'm checking -5 volts directly on the LM324, and ground is connected to a nearby pin of the modem audio connection. So we don't have any leads, any extensions here. 3, 2, 1, go. Would you look at that? The noise has disappeared. So what was measuring before was basically noise being picked up by that little extension. So unfortunately, that's a good example of improper probing. Now this is the -5 volts directly from the power supply without extensions, and I've changed the vertical resolution, so no worries there, nothing horrible is happening right now. But my oscilloscope says that we have about 450 millivolts of ripple coming from the power supply, unless I'm picking up something else. So I think we have a little bit of time to improve things further if possible. I'd like to take a look at the power supply, which is the last point that was mentioned on start.co.uk. I'd like to open the power supply and see whether there's anything that we can do to improve the situation there. We've been here before, right, in episode number 1, and there are not many capacitors on this power supply. There's only 10 capacitors. So I think I'll go ahead and just recap this thing. There is at least one capacitor here on the -5 volts line, which I believe is generated by a linear voltage regulator, so it should be very clean. But I think, honestly, considering it's only 10 capacitors, it's probably faster to just replace them all. Assuming I have them, I don't know. Now, one thing I'm noticing is that in order to remove the capacitors, I have to remove these heatsink. The heatsink is connected to the regulators and the transistors. And the heatsink is attached to the PCB via 2 Phillips screws. And these screws have been kindly soldered on. So I can't really use the screwdriver. I can try with some pliers maybe, but maybe I can try with some wick first. On the heatsink, we have 2 diodes, S10S C4M, and then we have a 7905, and this is the linear voltage regulator for the -5 volts. So in theory, there shouldn't be any ripple coming out of this regulator. It's a linear regulator, so the output should be perfectly fine. And I don't think that the capacitors here are at fault. But we are here, it's really 10 capacitors. Let's swap them all anyways. For future reliability, then if it does improve on the noise on the speaker, well, even better. Ma dimma zoppa. Oh, incollato. The first 3 capacitors are 2200 microfarads, 16 volts, and despite being very old, they actually read pretty good. Because the capacitance is more or less there, 2130, it's within tolerance. Electrolytic capacitors are plus or minus 20%. And the ESR is very low, 45 milliohms. The other 2 read exactly the same. This is a brand new one. It's the Panasonic FR series, 105 degrees, very low ESR. It's one of the best capacitors that you can find, and it's reading obviously the correct capacitance and 55 milliohms. So these seem to be totally fine. As usual, when it comes to capacitors, there's some people who are against replacing capacitors just for the sake of replacing them. Some people are saying, no, you must replace them all, otherwise everything, the world will implode and disappear. I tend not to replace them all just for the sake of doing it. In this case, only 10 capacitors. The unit is very old. We are tackling some noise on the speaker. We've improved with some capacitors. Let's replace them all and see what happens. It doesn't hurt. That's the point. I see what might look like the early stage of leakage or maybe some little corrosion on the legs of the capacitors, but it also be some residues from manufacturing. So I don't really know. And again, we'll replace them anyways. The next capacitor is 470 microfarad at 25 volts, and this is definitely leaking. It smells of fish as well. Not a huge amount, so no damage on the board, but it still reads, I would say, totally fine, because it's reading 480 microfarad, and well, the legs are a bit dirty, so something like 100 milliohms as ESR. And I have here a Rubicon. It's 470 microfarad, 35 volts, YXJ. I can't remember exactly the specs of this, but I tend not to buy crappy capacitors. And this is reading, obviously, the correct capacitance, and 133 milliohms. So this, despite leaking, is actually still looking pretty good. Now, this definitely needs to be replaced. And this is finally the one on the minus 5 volts line, 220 microfarad, 25 volts. Oh, I didn't realize these are 105 degrees, so actually good quality. And this is reading the correct capacitance and something like 190 milliohms as ESR. Now, this is another FR from Panasonic, and surprisingly, it's actually reading a little bit more of ESR. These are very low ESR, so I'm actually surprised that this very old one is reading a bit less than that. But again, these, I don't think you can buy anything better in terms of ESR than the FR series from Panasonic. At least this is the one I buy. They should be the best in terms of low ESRs from Panasonic. And the next capacitor, it's another 220 on the minus 5 volts line, but it's a different brand. It's a Tracon, and it's actually reading considerably worse than the other one, 700 milliohms as ESR. So I'm going to replace it again with another FR from Panasonic, which in this case, it should be considerably better at 230 milliohms of ESR. Interesting. The last capacitor, it's another Tracon 2225 volts. This is definitely showing signs of leakage, and it's reading 2000 microfarad, and ESR is still low at 79 milliohms. I'm replacing it with an Nichicon 2225, which is more or less reading the same. So again, capacitor was probably still okay, but leaking, and definitely it needs to be replaced. Next capacitor is another Tracon 220 microfarad, and it's reading a good capacitance, but it's 1.62 ohms of ESR, and the Panasonic FR I'm replacing with, as before, has an ESR of 260 milliohms, so it's quite an improvement. Marimma impestata ladra, ma che è? Oh! La colla ci hanno messo. Cosa c***o è? Quelle carte che si stacca, ostia.
Le si tacca con la colla e non le si stacca, ma è una roba, guarda.
The final two capacitors are the ones on the primary. They were glued on the PCB, so it took me absolutely forever to take them off without damaging anything. And they are 100 microfarad, which is very little, but 250 volts. I'm going to replace them with two Rubicons, 100 microfarads, but 450 volts. You can always install something a higher voltage, not lower. Now, surprisingly, these old capacitors, they still read the right capacitance, and also a very low ESR at 470 milliohms. And the Rubicon I'm using to replace them, well, the capacitance is still more or less in spec, but the ESR is actually higher. I don't think it's going to make a difference on the primary of the power supply, but it's actually quite interesting to see that it looks like they use pretty good capacitors on this power supply. Now, let's clean up this mess and install these final two capacitors, and then we'll test it. Everything is back in one piece. It's time to test. Will it work or will the magic smoke be released? Let's find out. 3, 2, 1, go. Well, it seems to be working. We've got 5 volts. We got this 12 volts, which is never very accurate. It's only for the drive, and minus 5 volts. So everything seems to be working fine and no magic smoke. Well, that's great news. Let's put it back together in the BBC Master and see whether it made any difference whatsoever. And no, I don't think there is any further improvement more than these, and I think I would be chasing ghosts, because the speaker is already very quiet. After all, this is a 40 years old machine, and probably this little noise is by design. The leftover noise is probably coming from digital signal on the board, just managing to get through sound. Those are not easy to remove, especially if the PCB is designed in a way where some noise manages to get to the audio output. So I think this is totally acceptable for what I wanted to do, but if you do know some extra tricks, do leave a comment down below. I'm really curious to hear whether there's anything extra and simple that can be done to improve on this. And just as a reference, this is what the minus 5 volt signal is reading, and I'm comparing with exactly the same vertical resolution as before, so there's really no improvement to what we had before. And this is plus 5 volts with the same resolution as before, and once again there is no improvement, but again the power supply needed a recap, so happy days. But I'm pretty happy with the outcome. We managed to remove basically all the noise from the speaker, and we also managed to service the power supply, which wasn't in horrible condition, but it was about to get wrong, so I think it was the right time to service it. And now that we removed the noise from the speaker, I think it's the right time to finally return this machine to its owner in Portugal. Thank you, Peders, for sending me this machine, and I hope you enjoyed it, and also I hope you all enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget, I'm on Patreon and on Facebook, and the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very much understandable, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, which is also very much understandable, well, I hope you enjoyed the video, and I thank you for your time. That's it for today. Thank you for watching. I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.